Okay, so today we're going to be talking about some operations with rational numbers, and specifically, we are going to, let's try spelling right. We're going to multiply and divide rational numbers. Now, the biggest thing to remember is that all of your rules for integers also apply to rational numbers. So it's something that you need to be considerate when you're doing this. There are simple rules for multiplying and dividing when we're talking about rational numbers. And really when we're talking about rational numbers, in this case we're actually going to talk just about fractions. We can keep it very simple. We can get a little bit more complex. And I think what I want to do is show you a different way of doing this. A way that most people don't do fractions. So for example, if I did 2/9 times 3/14. Now you probably learned how to cross cancel and all that, but I want to show you a different method. And the reason I like this method the most is because it will always give you an answer in simplest form. So what I do to change this up a little bit is instead of cross-canceling, I prime factor. So let's take our fractions and let's prime factor. Prime factor of 2 is just 2. Prime factor of 9 is 3 times 3. 3 is 3. And 14 is 2 times 7. Now all I have to do is cancel out prime factors that are similar. So for example, I have a 2 on top and a 2 on the bottom. I could get rid of that. I have a 3 on top and a 3 on the bottom. I could get rid of that. Now, what's left on top, you would probably say nothing, but there is something left on top. Because whenever everything cancels out, it usually leaves a 1. And 3 times 7 is 21. So the answer is 1/21. So, simple enough. Here's one for you to try. 3/4 times 8/21. Pause the recording and you try to figure out the answer to this one. Okay, you're back. Let's see if you got the answer correct. If you did it right, you did 3/2 times 2 times 2 times 2 times 2 over 3 times 7. You canceled out the 3's, you canceled out a 2, you canceled out another 2, and you were left with 2/7. Did you get that right? Good, I thought you may have. So now look at these two. And well, before you look at these two, let's talk about negative numbers. Negative 18. What is the prime factorization of negative 18? Yeah, this one can be a little bit tricky, but in reality, we know 18. We know that's 2 times 3 times 3. But what about that negative? That negative sign is really saying -1 times 18. So when I prime factor this, it really is -1 times 2 times 3 times 3. So whenever you have a negative number, you always want to pull out that negative sign, or the -1 for the negative sign. Okay, take a look at these problems. 3/4 times -7/9. And go ahead and try 2 1/3 times -2 5/7. Pause the recording and try your luck. Okay, if you did it right, you said this was 3 over 2 times 2, negative 1 times 7 over 3 times 3. You said the 3's canceled, and you got negative 7 over 12. On the second one's a little bit trickier because you actually, if you remember from before, you can't multiply mixed numbers. You have to turn them improper first. So this starts as 7/3 times negative 19 sevenths. And so, being that those are all prime numbers to begin with, the 7's cancel out and I get negative 19 thirds. And yes, I really probably should have said this is negative 1 times 19. The multiplication is pretty straightforward. When we're talking about division, on the other hand, when we're dividing rational numbers, this is a whole nother issue. And dividing rational numbers uses our phrase, keep, change, change again. But in this case, we're going to keep the first fraction the same. We're going to change division into multiplication. And we're going to change the second fraction. Before we do this, let's back up for a second. A over B divided by C over D. So if I do my same change, as I just said, keep the first fraction the same, change division to multiplication, and we're going to turn the second fraction into its multiplicative inverse or its reciprocal. Then, of course, I could prime factor and multiply across. So let's take a look at a problem here. 1/9 divided by 5/12. Done properly, you would have rewritten this as 1/9 times 12 over 5. Prime factor, that's 1 over 3 times 3. That's 2 times 2 times 3 over 5. Of course, I can cancel out a 3, but that's really it. And what I end up with is 4/15. Okay, you try this one. Negative 4 2/3 divided by 3 1/9. Pause the recording and give this one a try. Okay, let's see how you did. If you first did this one and said this was negative 14/3 divided by 28/9, you're on the right track. If you then said, well, this is negative 14/3 times 9/28, nice job, you're still doing it right. If I want to prime factor this now, prime factorization of negative 14 would be negative 1 times 2 times 7 over 3. This is 3 times 3 over 2 times 2 times 7. Let's see, I see a 2 canceling. I can see a 7 canceling. I see a 3 canceling, which leaves me with negative 3/2. And folks, you can leave it improper as long as we're not doing a word problem where it's not going to make sense if you say negative 3/2 feet. Then it's okay to leave it as a word problem. Or as an improper fraction, sorry. Now, here's a problem I'm going to give you. This is the last problem I'm going to give you, but I'm not going to give you the answer. This is one I want you to come in tomorrow showing me how to do. This one is algebraic. So this one's going to be a little bit different, but take a look. 4x squared y over 15 divided by 3x y cubed over 25x. Can you, let's do, x cubed. No, I don't like that. Okay, let's erase that. I want it to be x to the 4th. Now, see if you can figure this out. Now, not anything different. It's very much the same as what you've done before. Good luck, and I'll see you tomorrow.